Bara?
Yes.
Okay. So today we will finish unit 2. Okay. The left is what? Electric charge. So in this lesson, you need to know identify common materials that are electrical conductors and insulators. Okay. And why we have conductors and insulators, and also including metals and plastic. Okay, so we said before conductors have free electrons, but insulators don't have free electrons. And also we have a practical investigating how insulating material can be charged by friction. Also explain how positive and negative electrostatic charge are produced on materials by lose and gain electrons, and know that there are forces of attraction or repulsion between charges. Explain electrostatic phenomena in terms of movement of electrons. Also explain the potential dangers of electrostatic charge, example when fueling aircraft and tankers. Explain some uses of electrostatic charge like photocopier and inkjet printer, and also precipitator. We will take all of this. Okay, so today we will finish all of this. So first, Ahmed, what is the types of material? We have 3 types of material. What are these?
Conductor, insulator, and semiconductor.
Okay, now conductors, you have to know that conductors have free electrons. So electrical conductors or thermal conductors, all of these conductors have free moving electrons. It can transfer from one atom to another atom. This is why it can conduct electricity. A material that allows charge to flow through it easily, okay, and like metals, okay, and metals is a good conductor due to it has a free electrons. Okay, Bara, what about insulators? What about insulators? Yes, material that
doesn't allow electrical charge to flow.
Okay, why this material doesn't allow electrical charge to flow through it? Because it doesn't have what? Bara.
Free moving ions.
لا, free moving electrons, not ions, Bara. There is a big difference between ions and electron, okay?
Electrons.
Do you know what is the difference? Do you know what's the difference between ion and the electron? Do you know, Bara? I'm asking you. Let your mic on.
Yes.
Do you know what's the difference between atom and ion and electron?
No.
Okay, tell me no. Okay, why you take a long time to tell me? Okay, the difference is what atom, when atom lost electron, it becomes ion. So ions, in fact, is atom, but lost or gain electron. Okay, so there is why there is a big difference between electron and ion, because ion is atom, but this atom lost or gain electron or more. Okay, so we can't replace electron with ion. Okay, Bara. So if you write ion instead of electron, it will be wrong, totally wrong. Okay, Bara? Bara. Bara.
اوكي
براء، هو انت ليه بتاخد وقت عشان تجاوب؟ ده من
اوكي انا قلت اوكي.
ده من النت يعني ده بياخد لونج تايم عشان النت، ولا انا مستعجل ولا ايه؟ ولا انت بتكون قافل المايك؟
انا جاوبت والله، هو النت. انا جاوبت.
ممكن يكون النت بقى. ماشي، اوكي، ماشي.
النت انا جاوبت، انا قلت اوكي.
اوكي براء، اوكي. Now you can make your mic off. Ahmed, what about semiconductors?
These are in-between materials. They are poor conductors on cold, but much better conductors on warm.
Okay, so now semiconductors, it can be conductor or insulator. It depends on what? Some factors like temperature, like light, like this. Okay? And for example, we take diode. Diode is made of semiconductors. So we can write diode is made of semiconductors. Okay? Okay. So now, as you see in this table, conductors, we have good conductors and poor conductors. Good conductors, all metals are good conductors, okay? And also carbon is a conductor. Poor conductor like water, human body, and the earth. What about semiconductors? We have only two examples, silicon and germanium. Insulators like PVC, polythene, perspex, glass, rubber, wood, dry air, all of this is insulator. All of these are insulators, okay? So, Bara, give me an example for insulator.
Glass.
Glass, okay. Ahmed, give me an example of a conductor.
Aluminum.
Okay. Now we will take the first experiment, how to investigate the charging by friction. Okay, so maybe in the test he will ask you to write this experiment. So you have to understand this experiment and try to write it more than one time to be sure you can answer the question. So first, what is the variables? The aim of this experiment is what? The aim is, make it bigger. The aim of this experiment is to investigate how insulating material can be charged by friction. So what do you need to charge an object by friction? You need two objects. The object which will be charged and another object. Okay? So what is the variables in this experiment? The independent variable is rods of different material. We will try to charge a different material object. What is the dependent? The charge on it. And what is controlled? Time spent for rubbing, using the same type of cloth which are used to rub the object, using the same length of the rod. So we can say this is the controlled variable. Okay, now this is the experiment. Equipment required and the function of each one. So first we need polythene rod. I will explain the polythene rod in the experiment, and rods of different material, and the cloth to rub the rod with it, a cradle and nylon string and wooden stand. Now let's move to the experiment. As you see in the steps, what we have here, wooden stand, right, and nylon string, and this is the cradle, and this is the polythene rod. We will rub the polythene rod from both ends. Okay? And as you see, the polythene rod is easy or free to move. After that, I will bring the rod with different material. Yani you can, for example, this is material 1. And we will rub this object also from both ends. Okay? Now, we can make the object, okay, closer to what? The polythene rod. And we will watch if this attract or repel or nothing happen. If the object attract or repel to the insulating material, what it means? It means there is a repulsion or attraction force. It means this object is what? Charged object. If nothing happen, it means this is not charging object. Neutral object. Okay, so again, this is step number 1. Ahmed, can you read step number 1?
Take a polythene rod and hold it at its center and rub both ends with a cloth.
So this is the polythene rod and rub from both ends. Okay, and what? Hold it in the center, right? So number 2, Ahmed.
Suspend the rod without touching the ends from a stand using a cradle and a nylon thread.
Yes. Next.
Take a Perspex rod and rub it with another cloth.
Yes.
Without touching the ends of the Perspex rod, bring each end of the Perspex rod up to, but without touching each end of the polythene rod.
Okay.
Record any observations, repeat for different
Okay.
materials.
Repeat the experiment with different what?
Materials.
Material. Different material means this is the independent. Okay. So do you understand the steps, Bara?
Yes.
Okay. Now, analysis of result, Bara. Can you read the analysis of result?
When two insulating materials are rubbed together, electrons will pass from one insulator into the other insulator. A polyethylene rod is given a negative charge by rubbing it with the cloth. This is because electrons move from the cloth to the rod. Electrons are negatively charged, hence the polyethylene rod becomes negatively charged.
Okay, so now as you see, when you rub two objects together, one will lose electrons and the other one will gain these electrons. Okay, the object will lose, it will be positively charged. Okay, and the object will gain, it will be negatively charged. So, for example, explain, Ahmed, why this rod has a negative charge when it rubbed with the cloth.
Electrons.
When it
It
rubbed
gained
with this cloth.
electrons.
Yes?
It gained electrons.
It gains electrons from cloth. And Bara, why this cloth gain a positive charge?
Because it lost electron.
Yes. What if he said, this object, we have positive charged move from rod to the cloth. Is this correct or incorrect, Bara? Is the rod becomes negative
Yes.
because the positive transferred from the rod to the cloth? Is this correct?
يعني من النيجاتيف للبوزيتيف.
يعني الرود دي بقت نيجاتيف because الرود دي كان عندها بوزيتيف والبوزيتيف مشيت راحت للكلوث. Is this the reason this is negative and this is positive? Is this the reason? Or the reason because electrons transferred from cloth to the rod? Which one is correct?
And the second one.
The second one, what is the second one?
البوزيتيف بتاعت الكلوث ترانسفير للرود.
You mean electrons transferred from cloth to the rod. Yes, this is correct. So we don't have positive charge in electricity can transfer. Because what? Because in fact, if this is atom, we have nucleus, it has the positive charge and the electron charge, it rotate or orbit the nucleus. So this is why the only charge can be gained or lost is electrons only. Okay, so if he gives you any positive charge gained or lost, it will be totally wrong. We don't have positive can be transferred because the positive charge, which is protons, cannot leave the nucleus. Okay, so every time he will ask you about the charge, you will say, what is the charge, Bara? What is the charge, Bara?
يعني ايه what's the charge?
What is the charge transferred from one object to another object?
Electron.
Electron, yes. And it has or it carry a negative charge. Okay, and also is this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? It means it gains 9 electrons. So I will write 1, 2, 3, 4, 5, 6, 7, 8, 9. Now we have 9 positive because it lost 9 electrons. Do you understand? Ahmed, do you understand?
Yeah.
Okay. Now, what is the type of force between the rod and the cloth? Because they have, unlike a charge, one positive and one negative, they will attract each other. Okay? So, now I explained how the rod becomes charged object. If you want to be ensured that the rod is charged or not, you have to make it closer to a charged object. If this attracted or repelled, it means this has or carry a charge. Okay, this is the experiment. Now, as I said, in the material, and also you have to know, to gain or lose electrons, you need what? You need insulators. So our experiment about insulators, and we can't charge the object for a conductor because conductor allow charge to flow through it. So the charge will flow through it to the earth. So we can't do this experiment, and the result of the experiment, the charged object cannot be gained using conductor. Okay, so if the material is repelled from the polythene rod, then the materials have the same charge, because same charge positive repel positive, repulsion force. What about negative and negative, Bara? Repel or attract?
Attract.
Negative and negative, Bara. Attract or repel? It will repel, Bara, because same charge repel. Okay? Like a charge repel, Bara. Okay? Ahmad, what about positive and negative?
Attract.
Attract. So it means unlike, attract, and like a repel. So if the material is attracted to the polythene rod, they have positive charge, opposite charge. Opposite means unlike a charge. Okay? So now we have finished the experiment. Now production of static. If you need static electricity, you need an insulator. You need an insulator because insulator doesn't have free electrons. So charge cannot flow through it. When a certain insulating material are rubbed against each other, they becomes electrically charged. This is charged by friction, like as you see. Okay, the charges remain on the insulator and they cannot immediately flow away. One becomes positive and the other becomes what? Negative. An example of this is plastic rod and the polythene rod being charged by rubbing with a cloth. Okay, this occurs because electroscope. This device is called electroscope. Okay. So now this is the electroscope. We call it gold leaf electroscope. Gold leaf electroscope. Okay. So now we have a negative rod. What will happen, Ahmad, if I move the rod toward this gold leaf electroscope? What happened to the leaf at the bottom?
It will become more negative.
Now, yes, and also the leaf is what? Repel, right?
Yeah.
Okay, it moves up away from the other leaf, right?
Yeah.
Because they have the same charge, so they repel. When I move it away again, it becomes stick together as the beginning. Okay? Okay, Bara? What we call this device? Electroscope. Gold leaf electroscope. What if the object is positive? Also, if I move the object closer, so now what happened to the gold leaf again? Repel. Okay? So if he asked you, How can you investigate if the object is charged or not? You can say what? We will use a gold leaf electroscope. Okay, move the object closer to the gold leaf electroscope. If the gold leaf repel, it means the object is charged. If the gold leaf doesn't move, it means it is not charged. Okay. Okay, let's continue. Any question until now? Any question, Ahmed? Do you have any question?
No, thanks.
What about you, Bara? Do you have any question until now?
No.
Now we'll talk about electric force between charge. So again, Bara, what is the charges we know? What is the particles have a charge we know? We have positive, negative, and neutral. Give me an example for positive object, Bara. Bara.
Yes.
Give me an example for positive object or positive particle.
Positive.
Yes, particle carry a positive charge in the atom. Nucleus. Okay. What's inside nucleus carry a positive charge?
Proton.
Yes. And what about negative charge?
Electron.
Yes. What about neutral charge?
Neutron.
Yes, right. Yes, right. Electrons are negatively charged particles, whilst proton are positively charged, and also neutron is a neutral. This is why in neutral atom, the number of electrons equal number of protons. Now, an object becomes negative if he what? Gains electrons. And positive if he loses electrons. If the charges are same, they will repel like this. If they are unlike or opposite, they will attract. So now positive and negative attract, negative and positive attract, negative and negative repel, positive and positive also repel. Attraction and repulsion between two charged objects are examples of non-contact force, like gravity, like magnetic force. So all of this called non-contact force. This is why we have electric field. This is a force that acts on the object without being physically contact with it. Now movement of electrons, as we said, okay, the object will lose. Now if we want the direction, now we can say electrons move from the positively charged rod to the negatively charged cloth, right? So the object will gain electrons, will become negative, and the other one will become what? Positive. What if we have charged object closer to neutral object? What will happen? Attraction of uncharged object. So we said before, positive to negative attract. Positive facing positive repel. What about if we have positive with neutral, no charge? What will happen? It will be, in fact, attract. Okay? Like a piece, like when the ruler attract a pieces of paper. Okay? I can make this experiment and send it to you in a short video. Okay, now, attraction of uncharged object. As you see, when a charged rod is put near a metal foil, this is a metal foil, okay? Electrons of the foil are pulled toward the rod. So now, as you see, electrons pulled to face the positive charged rod. So what happened to the bottom, at the bottom? Now it becomes positive. So top of the foil is negative and the bottom now is positive. So now we have attraction between negative and this positive, which becomes greater than repulsion between this positive and this positive. This is why the resultant is what? Attraction force. So if we have positive with negative attract, positive or same charge repel, but charged object with neutral, it will be also attraction. Any question, Ahmed?
No.
Okay. So Bara, as we said, if we want to check if the object if we can detect the charge using what? A gold leaf electroscope. So we call this device gold leaf electroscope. Sometimes they will write it like this, GL electroscope. Can be written like this in the question. Okay, so as you see, in fact, the gold leaf electroscope itself doesn't carry any charge. If we bring a negative rod closer to the electroscope, now what happened? The negative here will escape. Escape to what? The gold leaf. So now we have negative and the negative, so it will repel. Also, this happens if we also bring a positive charged object closer to the electroscope. Bara, do you understand?
Yes.
Okay. Ahmed, do you understand?
Yeah.
Yeah, because I did it in the experiment. Okay. Now, what is the unit of a charge? Coulomb is the unit of a charge. The symbol is what? C, Coulomb. So charge, symbol of a charge is Q, and unit is Coulomb. Now the next is using of static electricity. How can we use static electricity in our life? The first one is electrostatic precipitators. Okay, it's a type of filter, so we can see how it works. We can see how the precipitator work.
Visualized through 3D animation about the theory of electrostatic precipitation. As a discharge phenomenon occurs, ionization occurs in the air that...
So in fact, the method is what? This is the smoke particles. We will charge the smoke particle with positive or negative charge. Then it will move toward an electrical field, so it will attract to the plates like this.
Positive or negative polarity.
So this is the first step. We will charge the particles of the smoke particles. We will charge it by conducting. So any particle touches the positive plate, it will become the positive. Any charge, any particles of the smoke touch the negative plate, it becomes negative. Okay, so this is the first step.
The air has positive or negative polarity. Therefore, thus that joins the air has a negative and positive polarity as well. Now we must draw that they are positively and negatively charged.
So now in the second part we have this is negative and this is positive. So as you know, if this positive, it will attract to the negative plate. If it is negative, it will attract to the positive plate. Okay?
Act of extraction is called dust collection. In an air purifier, there are electrodes installed in it. The positive and the negative electrodes. The positive electrode attracts negatively charged particles. The negative electrode attracts positively charged particles. So the dust that comes inside the air purifier, negatively or positively charged, is attracted by the electrodes and thereby being trapped inside. The air that is free from the electrical charges is then released back in the environment as a clean air. The air now has been cleaned and purified. This process of cleaning the air through
So as you see, this is the air with the smoke. Okay, when it enters the filter, it will be charged. After that, it will face positive or negative, so it can be what? Attracted. It can be charged in the filter. After that, it can be attracted to a positive or negative plate. So now we will gain
this device is called
air
electrostatic
without any smokes.
precipitating or simply air purifying. Hence, the device is called an electrostatic precipitator or simple air purifier. I already mentioned some important technical terms like electrical.
So this is the same, but in only 10 seconds. As you see, this is the filter, and this is the air with pollution, smoke, and particles. Okay, so it will travel through the filter. It will be charged, right? After that, it will be attracted to the plates, positive or negative. So now we have a clean air. Okay, we have a clean air. Ahmed, do you understand how electrostatic precipitator work?
Yeah.
In the test, he will not ask you to explain how it works, but sometimes he will give you the device and the contents and ask you how it works. So at least you have to know how it works. First, the smoke particles will be charged. After that, it will move through the plates, which is positive or negative. The charged particle of the smoke will be attracted to the plates. So now the air will be clean without any smoke particles. Bara, do you understand the electrostatic precipitator?
Yes.
This is the first use of the static electricity. So if he asks you, right, two uses of static electricity, we have three. You can choose any two. After that, the photocopier, how we can make a copy for you.
The photocopy machine has following important components: a halogen lamp, a photosensitive drum, a toner or an ink drum, and a conveyor belt for loading.
Ahmed, can you listen to the sound of the video?
No.
You can't listen to the sound of the video. Okay. So now, as you see,
blank papers.
Okay, as you see, this is the contents of what inside the machine. If you want to make a copy, this is what's inside the machine. We have a halogen lamp, because if you want to make a photocopy, you can see the light, okay, emitting from this lamp. And also we have the drum, photosensitive drum, and we have the toner. Finally, we have the paper comes from this side, which is conveyor belt. After that, we have the dryer. Okay, so now how it works.
So here's how it works. When you place the document you want to be copied,
if you want to make a copy for this document, okay, so what is the first step?
Upside down on the glass and press the start button. An intense beam of light scans across the document.
Now this lamp will emit the light. The light will be reflected to the drum. But as you know, white reflect light. What about dark, black? Black absorb or reflect, Ahmed? Absorb. So black cannot reflect the light. So the only reflection by the white parts. The black, which is the words written in the black, okay? So the black cannot what? Reflect the light.
From top to bottom. This light then gets reflected and falls on the photosensitive drum. Now here's where the magic happens. This photosensitive drum is a metal roller which is electrostatically charged by.
So now as you see, the drum has what? negative. Sometimes in another type of printer it has positive. So now, for example, if this has negative, what happens when the light fall on it? The electrons will what? Will move away from the drum. Okay, so
a high voltage wire called a corona wire. This metal drum is coated with a photosensitive chemical called selenium. It is a semiconductor, so it has the property to act as an insulator in dark areas, and when light falls on it, it conducts electricity.
So as you see in dark area, insulator in dark area, so the dark area will be insulator, so it doesn't allow charge to flow. Okay, while conducts electricity when light falls. So when the light falls, it will take the electrons to this voltage, but the rest will be negative here or positive. It depends on the type of machine. Okay, now what happened after that?
Now have a look at the document we wanted to copy. When a beam of light
So now all of this light will reflect it, but for the black, it will not reflect the light.
was scanned across the document, light got reflected from the white areas, whereas printed letters being black did not reflect any light. When this reflected light falls on the photosensitive drum, the areas of the photoconductor which was exposed to light becomes conductive and gets discharged, whereas the area of the drum which was not
So as you see, all electrons move away from the light, and for the dark, there is electrons. Electrons cannot escape in the dark area.
exposed to light remains negatively charged. Thus we get an electrical shadow of the page on the photosensitive drum. Further, as the photosensitive drum rotates, it carries this electrical shadow towards the
So now this is negative, okay, and this is the tuner. Tuner will be positive in this type of machine.
toner. The toner is a positively charged, so the toner particle sticks to the electrical shadow which is negatively charged.
So now the negative will attract the tuner, which is positive.
Thus, an inked image of the document is formed on the drum. Then, a blank sheet of paper is fed up from the hopper. As it moves along, the paper is given a strong
Now the paper, the white paper, has a higher attraction electrical force. Okay, so this is negative, okay, but with a greater force.
electrical charge. Thus, the toner image is transferred from the surface of the
So now as you see, the white paper will attract the tuner here. Okay, now
drum onto a piece of paper. This paper then passes through two hot rollers. The heat
now this is the heater to make the tuner what? Dry, okay, to make it stick in the paper.
and pressure from the rollers permanently fuses the
In fact, this is the steps how the photocopier happen. So now we can read the steps. Ahmed, can you read the steps?
Photocopiers use static electricity to copy paper documents, most commonly in black and white. An image of the document is projected onto a positively charged copying plate. The plate loses its charge in the light areas and keeps the positive charge in the dark areas. A negative charged black toner powder is applied to the plate and sticks to the part where there is a positive charge. The toner is then transferred onto a new blank sheet of white paper. The paper is heated to make sure the powder sticks, hence why photocopied paper feels warm. The photocopy of the document is now made.
So do you understand, Ahmed?
Yes.
Okay, Bara, do you understand? What is the steps?
Yes.
Okay. Now this is the steps also. So the first step is what? The image of the document is projected onto a positively charged copying plate. After that, what happened? Where light falls onto the plate, the electrical charge leaks away. Okay, now negatively charged plate, black tuner particles are attracted to the remaining positive area. After that, paper is placed over the copying plate, tuner is transferred to the paper and heated to make it stick. Finally, we have the paper with the copy, okay? Now, insecticide sprayer. Also, sometimes he will ask you about this. because as you know, when we use a sprayer, we have the liquid is moving like spread out like this, like when painting, for example, when painting a car. So insecticides are chemical used to kill pests in order to protect crops. Okay, now to make the insecticide spread out and cover a large area, we need to use what? A sprayers. Lost our time now. Okay, to achieve this, the insecticide is given an electrostatic charge. So the idea is what? The liquid inside the insecticide here, the liquid inside it, it must be charged. Okay, charged by friction. It will be charged by friction due to the gun because it's moving fast. And because all droplets have the same charge, it will repel, so it will move away, so it will spread out and covering a large area. So the droplets of insecticide then repel. So the first step to achieve this, the insecticide is given an electrostatic charge, for example, positive or negative, as it leaves the sprayer. The droplets of insecticide then repel each other since they are the same charge. This ensures that the spray remains fine and cover a large area. They are also attracted to the negative charged on Earth, which make it what? Fall quickly and are likely to blown away. A similar technique is used in what? Sprayer painting of cars. But in this case, we will make the body of the car negative charge or positive. Yani it must be the opposite charge of the painting. Okay? So do you understand, Ahmed?
Yeah.
Do you understand, Bara?
Yes.
Okay. Now the last thing is about dangers of static electricity. طبعا dangers of static electricity, it can cause a fire. Okay? By what? Static electricity can cause a spark. Okay? So for example, now what happened while fueling? While fueling, the fuel will move quickly through the pipe, which is made of insulator. So the fuel itself it will be charged. Okay? So now the fuel is running and the woman sit in the car. So now the body of the woman is again charged by friction because she's sitting now on the seat. Okay. So now what will happen? A spark, which cause what? The fire. Okay. So this is dangerous of what? Electrostatic. It can cause a spark, which cause what? There are various situations where static electricity can pose a hazard. For example, the risk of electrocution from lightning. Do you know lightning, طبعا? Okay, Ahmed, do you know what means by lightning?
Yeah.
Bara, do you know what's meant by lightning?
Yes.
Okay. The risk of the fire of explosion due to spark close to a flammable gas or liquid. There are dangers of sparking in everyday situations such as fueling vehicles, such as cars and planes. So what is the solution now? You have to earth. Earthing is used to prevent this. Okay? Because as you know, if you make earthing, what will happen? For example, if this is the object, if the object gain negative charge, okay, and for example, your hand is positive. So now what will happen? The spark will happen. Okay. So to prevent this Spark, what should you do? You have to earth the object. What's meant by earth? You will connect the object using a conductor to the earth. Now, what happened to the negative? The negative charge will move to the earth. Like what? Like this example. Now, this is charged, right? So, when I touch the plate, what's happened? The charge moved through my hand, okay, like this, for example. Now, this electroscope is charged. Bara, how many positive charge it has? How many positive do you see in the electroscope? How many positive?
Disconnected.
Huh?
Disconnected.
1, 2, 3, 4, 5. Sorry?
Disconnected.
Bara is disconnected. Okay. So Ahmed, sorry, Ahmed, how many positive charge you can see?
1, 6. And the leaf?
And all the device.
13.
And what about negative?
5. 6.
So what it means? It means this object is what? Positive or negative?
Positive.
Now, if I want to make it uncharged, so what should you do? Just connect it to the earth by touching it using a conductor. So now what happened to the object? It becomes what? Neutral again, right?
Yeah.
So this is what we need. Okay? You have to connect, you have to earth the object. You have to earth the car, or you have to earth what? The fueler. Okay? So as you see, earthing is used to prevent the dangerous build-up of a charge. This is done by connecting the vehicle to the earth with a conductor. So do you understand what is the dangerous and what is the solution to prevent the explosion, for example?
Yeah.
After that, we have an example, fueling vehicles. Now, can you read it, Ahmed, for me?
A buildup of static charge is a potential danger when refueling airplanes. Fuel runs through pipes at a fast rate. The fuel is very flammable. The friction between the fuel, a liquid insulator, and the pipe causes the fuel to gain charge.
Okay, so now what is the reason for charging the fuel? Due to friction between the fuel and the pipe. The pipe. Yes, so it will cause that's the charging for the fuel and also for the object, the car itself. Okay? And they have opposite charge. One will be positive, one will be negative. Okay. Now, if this charge were to cause a spark, what happened?
The fuel could ignite and cause an explosion.
This is why, as you see, while fueling the airplane, what happened? They connected its body to the earth. We call this earthing. So as you see, boiling line carries what? The charge to the earth, to reduce the risk of a spark and a fire. And what is the reason? Friction between what? The fuel and the pipes called the static charge build-up. This is important because sometimes he will ask you to explain why the fuel is charged. Okay?
Spark, like a fire.
Because the pipe is connected to the object.
Oh, okay.
And the object is metal. So it will gain electrons, but it is insulated to the earth because the rubber is insulator. So the body of the airplane will be charged. So I have to discharge it by connecting it to this wire. Okay?
Okay.
So now, as you see, this is prevented by the fuel tank being connected to the earth with a copper wire called the bonding line during the refueling. Okay? Two conductor earths the plane and carrying the charge through the earth, which remove the risk of the spark. Finally, we have this example, but in filling the missing places. like this. So can you read it? Number one.
As fuel flows out of a fluid pipe, static can build up. This can easily lead to a spark, and after a few places, boom. The solution: make the nozzles out of metal so that the charge is conducted away instead of building up. It's also good to have earthing straps between the fuel tank and the fuel pipe.
Okay, is this easy?
Yeah.
Okay. Okay, now we will start to solve the questions. Okay, so this is the first question. Can you read it and tell me what is the answer?
The diagram shows the rod and the cloth. When the rod is rubbed with the cloth becomes positively charged and the rod becomes negatively charged. Explain how the cloth has become positively charged. It became positively charged because because the cloth lost its electrons, so only protons stayed behind, which made the charge positive, as protons are positively charged.
Yes, so this question has 2 marks. When the rod is rubbed with the cloth becomes a positive charge and the rod becomes negative. Explain. So you can write what? Electron charge. Transfer or are transferred from the cloth to what? To the rod. Is this correct?
Yeah.
So you will gain 2 marks because you said the electron transferred. It means the charge will transferred is the electron. And from close to the rod, the second mark. Okay?
Okay.
So every time you have to mention what is the charge will transferred. Electrons or negative charge. Now the next.
The negatively charged rod makes contact with a metal object connected to the ground. There is an emitter in series with the object and the ground. Explain how the emitter shows a current for a short time and then shows no current.
Do you know what happened in this type on the second example? The negatively charged rod makes contact with a metal object. So for example, we have this is negative, right? Connected with a conductor to what?
The ground.
To the ground. We call this earthing. Okay, so and we connect a meter. So we connect an ammeter here. So the ammeter he said there is an ammeter in the series with the object and the ground. So now the ammeter in series with the object and the ground. Explain why the ammeter showed a current for short time and then show the no current.
Because the current goes to the ground and doesn't stay in the loop.
Don't say current flow. You can write electrons flew from the rod to through the wire to the earth. So it will give reading. Okay. After that, there is no electrons, so no reading. Right?
Yeah.
Do you understand the bara?
Yes.
Electrons flew through the conductor Okay. Now, Bara, it's your turn.
State the formula linking charge, transferred current, and time. الcharge transferred equals current times time.
Very good. Okay, continue.
The mean current displayed on the ammeter is 6.8 times 10 negative 6 ampere. The current lasts for 3.7 meters per second.
Meters per second? This is meter per second, Bara. But what about this?
Calculate.
What about this? This is not meter per second. What we call this, Bara? Ahmed, what we call this?
Millisecond.
Millisecond. Okay? So now we have millisecond. Because there's a big difference. Meter per second means this is velocity or speed. But millisecond, it will be time. Huh? So as you see, he gave us this one and this one. So what is the given he gave us with symbols, Bara?
We have the current.
What is the symbol of current in this equation?
Ampere.
What is the symbol of current in this equation? Bara. يعني the current is Q or I or T? I. So you have to write, this is the given. I, current, equals 6.8 multiplied 10 power negative 6 ampere. Okay? And what else he gave us?
Time.
Time. What is time equal, Bara?
3.7.
3.7 millisecond. Do you need to make a converting or not?
Yes.
How can you convert from millisecond to second?
Divide 1000.
Yes. So now what is the result in your calculator?
.7 times 10 negative 3.
Okay, now it's ready. Okay, continue. He said, calculate the charge transfer. So what is the symbol of a charge?
Q.
Yes, Q equal I
times T.
Yes. Now you can use your calculator.
.516 times 10 power negative 8.
Okay. Ahmed, can you solve this question?
A cleaning product is applied to a curve using a sponge pad. The sponge pad is rubbed against the curve to apply the cleaning product. Some parts of the curve are made of metal and other parts are made of plastic. The metal parts of the curve are earth. Explain why the pad becomes charged when rubbing the plastic parts, but not when rubbing the metal parts. Because metal parts allow charge to flow through it, while the plastic part is insulated, so it doesn't allow charge to flow through it. So the pad can lose or gain electrons when rubbing on it due to friction.
Okay, so now this question has 3 marks. So he said, what is the difference between, explain why the pad becomes charged when rubbing the plastic part, but not when rubbing with the metal part. So you can start with what? You can start with the pad become charging when rubbing with the plastic part. are insulator. Okay? Don't have free electrons and don't allow charge to flow through it. So it gains, or they gain, it gain electrons and become charged. While the metal part are conductor. So when it's charged, allow the charge to flow through it to the ground. Do you understand, Ahmed?
Yeah.
Do you understand, Bara?
Yes.
Okay. Now it's your turn, Ahmed Bart.
A sponge pad is held near a metal post that is connected to the ground. The sponge pad discharges with a small spark through the air to the metal post. The sponge pad stores 5 microjoules of energy
Micro
in
or
its
milli?
electricity. Milli?
This is milli. Micro will be like this. But
Okay.
this is milli. Okay?
Okay.
And
Sponge
also
pad.
this
Okay.
is mega. So this is a big difference between micro and mega. Mega is capital letter M. Okay?
Okay. The sponge pad stores 5 millijoules of energy in its electrostatic store. The voltage between the sponge pad and the metal post is 6,000 volts. Calculate the charge transferred by the spark.
Okay, so now what is the given?
Energy.
Energy? Yes, energy equal 5 millijoules. So can we convert it?
Yeah, divide by 1,000.
Yes, so what is the answer?
0.005.
0.005? I prefer to write it as 5 multiplied 10 power negative 3. Okay? Okay, and what else he gave you?
The voltage.
The voltage equal 6,000. And they asked to find what is the charge, right?
Yeah.
Do you know the equation, or you need the equation sheet?
It's energy over voltage.
Energy over voltage. Perfect, Ahmed. So energy is 5 multiplied 10 power negative 3 over voltage, which is 6,000.
6,000.
So what is the charge equal?
8.3
8.3 times 10
to minus 7.
Minus 7. Okay, now it's your turn, Bara.
The small spark between the sponge pad and the metal post demonstrates that the sponge pad is charged. Describe a different experiment that could demonstrate that the sponge pad is charged. You may draw a diagram to support your answer.
So what do you think? How can we demonstrate if the pad is charged or not?
We'll use gold leaf electroscope.
Right. We can using a gold leaf electroscope. Okay. By placing what? The sponge pad
pad. If they are
local
attracted, the pad is charged.
to it. If the leaf repel. بص براء، انت فاكر ولا نسيت الفيديو اللي انا عملته؟
أيوة.
بص براء اهو بص، لو انت قربت كده، هو لغايه دلوقتي الجولد ليف تحت في حاجه؟
لا.
when you make it closer what happened to the gold leaf؟ attract ولا repel؟ repel. يبقى if you make it closer to the electroscope and the gold leaf repel, it means the object is charged. Okay. If the leaf repel, it means the sponge pad is charged. Okay. Okay, Bara. Okay, now next. Bara, you can solve this also. Yalla.
The diagram shows the inside of an oscilloscope. Electrons leave the electron supply and accelerate towards the screen. The stream of electrons hits the screen. The grid is connected to the positive terminal of a high voltage power supply. Explain in terms of the movement of particles how the grid has become positively charged.
Yes, how this grid becomes positively charged.
It loses electron.
Yes, يبقى when it connected to the positive terminal, it lost electrons, so it becomes what?
Positively charged.
Positive charge.
Negative. Positive.
He said negative or positive?
Positive.
He lost the electrons, so if he lost electrons, it will become positive charge. Okay? Okay, Bara? Okay, now it's your turn, Ahmed.
Diagram 1 shows a circuit built by a student. Set the formula linking voltage, current, and resistance. Voltage equals current times resistance.
Yes.
Calculate the voltage across a 17 ohms resistor. So they gave us the current and the resistance. So convert the current into amps by dividing 83 by 1000.
Yes, perfect. So first the current is 83 divided by 1000 to convert it to ampere. Multiply 17. So what is the voltage?
1.411.
Huh?
1.411.
1.411 V. So it will be 1.4. Okay. State the voltage across 6.2 bara. We find the voltage here is 1.4 volt. What is the voltage across 6.2 bara? It has 1 mark.
State the voltage across.
Huh?
Yes.
We don't need to calculate it because we have what? A parallel connection. Okay, Bara? For parallel connection, what is the same? Voltage is the same, Bara. Okay? So we need to find the voltage only one time. Okay?
Okay.
So this is why the voltage will be also 1.4. Now he said calculate the current in the battery. He wants the current in the battery here. What do you think? What is the current in the battery? Huh? Can you find it with the easiest way? He wants the current in the battery. What should you do?
أعمل voltage divided resistance.
Where is the resistance? Bara, pay attention. We have current here and the current here, and we need the current here, Bara. Do you know? Do you know what to do?
No.
Ahmed, what should you do to find the current here?
83 plus 228 divided by 1000.
Yes, just you have to add this bara. This is the current in this branch, and this is the current in this branch. This is I1, for example. This is I2. So in the parallel connection, I total equal I1 plus I2. Okay, bara. Okay, and he need it with the same unit, so we don't need to convert Ahmed. Okay, so just add 83 plus 228. So what is the result, Ahmed?
$311.
It will be 3
1
1 1. Bara, if the question has only 2 marks, so it must be easy. Don't think about we need to find the total resistance in parallel. After that, we will find I equal V over R. No, this if you answer it like this, you will waste your time. So the easiest way, if you have the two currents, you can find what is the total current. Okay, Bara?
Okay.
Okay, now this is your turn, Bara. Huh? Did you study the parallel connection and series connection, Bara? Did you study?
What?
Did you study the parallel connection and the series connection or not? Because I said you have a test on Wednesday. So did you study?
Yes, I know.
Okay, so did you study or not yet?
Still.
Still. Okay. Can you solve this question?
Diagram 2 shows a second circuit built by the student using the same battery and resistor. Explain how the current in the battery will change now the resistors are connected in series. You do not need to do any calculation.
So what happened in series? Okay, if you don't know, I can ask Ahmed. Do you know? If you don't know, tell me about.
I don't know.
Okay, Ahmed, can you answer this question?
The series circuit, the current stays the same. So both resistors will have the same current.
So what happened to the current again?
In series circuit, the current is not shared and is the same everywhere.
No. Ahmed, read the question carefully. He said diagram 2 show a second circuit. okay,
Oh,
built by the student using the same battery and the resistor. Explain how the current in the battery will change now. The resistors are connected in series. So we have the total current here is what? 311, right? This is the total current in this case. Okay, so what about the total current in this case? Is this the same or will be changed?
it's the same because it's the same battery.
No. In series, the total resistance for 17 and 62 or 6.2 will be larger, right? Right, Ahmed? For this one, for this step?
Yeah.
يعني what is the total resistance here, Ahmed?
17 plus 6.2.
Yes. And what is the total resistance here, Ahmed? Will be 1 over R equal 1 over 117, right?
Yeah.
So it will be less. Okay? You can find it. It will be less than 6.2. Okay?
Yeah.
So now what happened to the total resistance now? It becomes greater in series, right?
Yeah.
Voltage
Stays the same.
stays the same. So I equal V R over R as resistance increase. What happened to the current?
Decrease.
Yes, the total current will decrease. Do you understand the Barat now? Barat,
Yes.
do you understand? Okay.
Yes.
Ahmad, do you understand my answer?
Yeah.
So if he said compare between the two circuits, you have to know what's the difference between current in the two circuits. And I didn't mention too the voltage. The voltage also change because the voltage for 17 is what? 1.4 for both. But in this one, it will be shared. Right? But he just asked to mention too the current in the circuit. Okay. Now, this question for you, Ahmad.
Photograph shows a person using a roll of plastic wrapping to cover a plate of food. The plastic wrapping sticks to the plate due to electrostatic charges. The passage explains why the plastic wrapping sticks to the plate. Use words from a box to complete the passage. Each word may be used once, more than once, or not at all.
Yes. So
The person pulls a layer of plastic wrapping from the wall. Forces between the layers of wrapping transfer particles called electrons from one layer to
now
another.
the first missing is electron. Okay, thank you. Now it's your turn, Baro.
The layer gaining those particles acquires a positively charged.
ليه positively charged Baro? Tell me. هي it gain what? It gain particles. What is the particles called, Baro? Electron. So if an object gain electrons, it will be positive or negative?
Negative.
Thank you. And what is the next? Baro.
Positive.
Ahmed. Next.
The negatively charged layer of wrapping repels positive. Wait. Oh. Electrons.
Yes. Bara?
The wrapping and plate attract
Yes.
due to the
Okay. Now the next. Ahmad?
The tumble dryer is a household device that dries clothes. The clothes rotate in a heated cylinder. Clothes often stick together when they are dry because they become electrostatically charged. A student investigates how different materials change charge electrostatically in the model tumble dryer. The diagram shows the model tumble dryer. This is the student's method. Put 4 dry squares of the same material into the cylinder. Rotate the cylinder at a constant speed for 3 minutes. Remove any squares that are stuck together. Measure the force needed to pull the squares apart. Repeat this for squares of different material. Name a device that students could use to measure a force, Newton meter.
Bara?
state the independent and dependent variables in this investigation. Uh, the type of material independent,
Oh, yes. Okay. What is the dependent?
and force needed
Yes.
to pull.
Because the independent is what we change, the dependent what we measure. Yes. Okay. State a control variable in this investigation. Bara?
Number of square.
Yes, because it said 4 dry square. Okay. And also the time, because he said 3 minutes, right?
Yes.
Okay, Ahmed, it's your turn.
Explain how the squares of the material stick together. Use ideas about electrostatic charge in your answer. Could you go up?
Okay, of course.
As the squares. Okay. Okay, as squares like move, it become charged due to the friction between the square and the tumble dryer, so they gain.
So we can write the squares. Okay, gain charge by friction.
Yeah.
Okay. After that,
Multiple squares can gain the same charge and an opposite charge. Squares can gain opposite charges.
يبقى the squares of opposite charge attract. Okay.
This causes them to be stuck together.
So they stuck together. Okay. Now it's your turn, Bara.
The table shows The table shows some of the students' results. Explain which type of graph is the most appropriate to present the results from this investigation.
Do you know the types of graphs ولا لا? Do you know? What is the types of graphs?
يعني
Types of graphs, in fact, Bara, we have different type of graphs. What we call this, Bara? A bar chart graph, right? And this
Yeah.
is a pie chart. Okay? And this is what? A line graph. So how can we choose which type is suitable? It depends on the data you have. Okay, if you have continuous data, you will use what? A line graph. Okay.
Okay.
If you have a categorical data, you will use what?
Bar chart.
If you have ordered data, also bar chart. Okay? So,
Okay.
categorical data like what? Different material. Ordered data like, for example, planets. Okay?
Okay.
For linear, continuous data like the relationship between current and the voltage. Okay? So, what do you think? In this question, what will you choose? We have materials and numbers. So, which one is suitable?
Bar chart.
Yes, explain why.
Materials are category data.
Yes. The bar chart. Because the data is what? Okay. Now this is the last question. Ahmed?
Set the formula linking charge, current, and time. Q equals IT.
Yes.
When the squares of material are pulled apart, there is a small spark. There is a current of 4.3 times 10 to the power of negative 6 amps in the air for a time of 2.3 times 10 to the power of negative 3 seconds. Calculate the charge as transferred. Okay, Q equals IT, so 4.3 times 10 to the power of negative 6 times 2.3.
Okay.
So 9.89 times 10 to the power of negative 9.
9.89 times 10 power?
Negative 9.
Okay. So now we have finished unit 2. So the test will be Wednesday. Do you think which one is better? Wednesday or next Sunday? Ahmed?
Wednesday.
Wednesday. Okay, Bara. The test will be unit 1 and unit 2. Unit 1 for motion, unit 2 for electricity. So Bara is suitable Wednesday. I said last week. So will you be ready? Bara?
Can I make it on Sunday?
ولا خليه Sunday السنة الجاية؟ ولا
لا
الشهر
مش السنة
الجاي؟
الجاية.
خلاص. I will make it on Sunday. It will be better for all of you. You can practice and also because I will send the homework. And I can make the Wednesday to solve any question or any problem in the homework. Okay?
Okay.
Okay. Any question?
No.
No.
Assalamu alaikum.